Hello, and welcome to Section 4.1 on areas and distances. Chapter 4 is concerned with integrals, a topic which is first found by exploring the area problem. Given a region in 2 dimensions, how do we quantify the amount of space it occupies? Throughout our mathematical lives, we've had to memorize the area formulas for special shapes. The area of a circle is pi times the square of the circle's radius. The area of a rectangle is found by multiplying its base length and height length. The area of a triangle is half its base length times its height length. What about the area of this region? Or this region? In order to determine the area of general regions, we must take a deeper look at the concept of area. Area is a measurement which is preserved through cutting and gluing and is unrelated to location. That is, a region's area is unchanged if it is cut, glued, slid, or rotated to a new location, as we can see with these triangular and square areas. The area of the square is just the sum of the area of the triangles. Area measurements are based on referencing the unit square. That is, a region that has an area of 30 square units can be cut and organized into 30 unit squares. With these observations, we are prepared to approximate the area of general regions. Let's take a region R that is formed by a function f of x as it passes from x equals a to x equals b. The general idea is to use familiar shapes which have easily measured area, such as rectangles in tile R. The result is that the sum of the rectangles is near the actual area of the region R, but clearly we are overestimating. Let's take smaller rectangles. Now clearly we are underestimating. You may be wondering how approximating areas by tiling rectangles belongs in a calculus course. Recall that calculus is the study of limits of change. Here, the area we wish to know is fixed, however, the tools we use to measure area can change. In the next sections, we will develop a method of approximating a region using in rectangles specially chosen to minimize waste. By increasing in and continuing to choose well-fit rectangles, the area approximation is improved. Here is where calculus enters the scene. We take the limit as n approaches infinity. That is, we keep refining our approximations by taking more and more rectangular tiles. You've seen the basics, now work towards mastery through practice and study.